Uh, Welcome today to the Clean Energy Transition of Islands in H 2020 funded project, present and future trends. Here today, I'm presenting a bit the agenda. I will make an introduction to this workshop, which is then divided in 4 thematic areas. First one about demand side management, flexibility, and energy management, made by Nikos Nikolopoulos from CERT. Then the second one is about renewables and energy storage technologies, presented by Joseph Mitsas from Veolia. Then we have one session about sector coupling, exceptionally presented by our colleague Alessandra Cuneo, who was a backup last minute, so a special thanks to her. And then we will have the last thematic session about regulatory framework and energy community, presented by Romain Mauger from the University of Groningen. Then we have a session slightly different, presented by Sinloc, Alessandra Montanelli, here today, thank you, about financing energy transition, the NESOI experience and the strive for innovation. We will have then a roundtable with some questions to the different presenter, and finally the conclusions by my colleague Gianni Lariga. A bit of history about why we are here today. Basically, we did in the last weeks different webinars organized around the 4 thematic areas that I presented before. Thematic webinars with many different projects involved, and we tried to get some sneak peek, some highlights out of these webinars, and we are presenting them today. So today in Rome, at Sustainable Places 2021, we are presenting some lessons learned. Why we are working on that? This is one slide that I presented in another occasion. Air pollution is a major cause of premature death and disease, and it's the single largest environmental health risk in Europe. It's particularly meaningful in this moment where we are coming out, hopefully, of nearly 2 years of COVID, where we had this huge problem in whole Europe and the world, but we have to consider that apart from the not negligible at all issues related to climate change, also air pollution is one risk, and it's not me, it's the European Environment Agency saying that. And a large share of the EU population is exposed to air pollution, much more than it should be, according to EU limits and targets or WHO guidelines. And this is because the modern society, as we know it, is born out of fossil fuel. The Industrial Revolution was born thanks to fossil fuel. But now the European Union, we are phasing out fossil fuel, hopefully, and leading this energy transition. Islands are one of the topic of today. In this map, I tried to spot the different islands that are involved in these projects that are involved today. Here I'm not including NESOI, which is aiming at involving many more islands, but you wouldn't see the map anymore if I put them all. And also, I didn't include many overseas territories just because they were out of scale. Within these webinars, within this project, we have more than 40 islands presented and many different solutions. I would like to say that every island is a snowflake, just because every island is different, has a different specificity and different characteristic. But as islands, as snowflakes, they have some common issues, common features. So this is a very nice metaphor, I think. As a follow-up, I would also highlight that we have a policy framework in place, which is quite new and very ambitious, and it is the Fit for 55 package. And we have the Renewable Energy Directive, which are setting the targets for the whole energy transition. And islands, as all territories, are very different, but even more than the mainland. So we are, even in the project, we have islands that are basically fossil fuel based and other that are already trying to be carbon neutral by 4 years from now. I would like to present, to briefly present the different projects involved, because in the next session you will hear something out of them, some outcomes, but basically you won't see a presentation of the different projects. First one is SMILE, which is the first project, I think, in order of time, just because it was not funded under a island call for project, but on a smart grid ones. And the idea was why not to apply these smart grid technologies to islands. There are 3 islands in Smile project: Orkney Island, Samso, and Madeira, and the scope is to demonstrate technological and not non-technological solution for these grids. Specifically, the focus is on demand response scheme and storage options. As said, 3 islands are the focus, and they are very different one among other. The second one that I'm willing to give you some words about is Janos. It's much more recent, and it started not even a year ago. And the objective is, as many others, broader, more focused on islands, to demonstrate a solution to decarbonize islands. How to do so? First of all, it's there are end user virtual power plant are involved as a mean for the decarbonization, and different tools and technologies are presented and promoted and developed. First of all, as you will hear in the next presentation, a strong focus is on people as players for this decarbonization. Then one other project is Insule. In this project, we have 3 islands. 2 of them actually are in common with Smile, which are Bornholm and Madeira, and another island is Unije in Croatia. In this case, the main focus is the investment planning tool, which is designed to guide the transition not only from a technological point of view, but also from this investment perspective. Of course, you can see on the right-hand side of the screen that different use cases as renewable storages, DC grids, and many more are included in this project. And the target of the project is to enable a average of 11% reduction in fossil fuel consumption on these islands, which is in the scope of a multi-annual but not so long project, already an ambitious target. One other project which participated to the session in the webinar and then presented today, it's GIFT project. As many other projects have the objective to increase the RES penetration, the renewable energy source penetration, increase the synergies among islands, archipelagos, and so on, and of course reduce the dependency from hydrocarbon. How it is doing it? Of course, with a grid IT platform, having many different objectives. Again, similar to Janos and similar to other projects working on the virtual power system aspects. So not anymore a central power station, but the centralized one, looking at the flexibility agents and flexibility opportunities on the island. And again, once more, the focus is on prosumers and the involvement of communities. Yes, one other project here represented today is REACT. REACT is as the objective of decarbonized islands. Once more, the focus is on island energy independency. How to do so? Of course, via renewable energy sources and storages. And again, there is this looking at ICT platform for the management of this renewable and storages. I know that it will be treated later on in today, but this is quite a crucial point why ICT is so important for the decarbonization of islands, just because we cannot just do things as we were doing it before, hoping for a different result. And of course, in this case, the need is also to leverage the different resources that are available to develop an energy model which is sustainable. Islander is a different project, is focused on Borkum Island, and in this case, it's more advanced than other islands. There are again the focus is strongly on sector coupling, how different energy vectors can be combined and managed in the best way to achieve this is one of the most ambitious one, where the target is about having the island fossil fuel free by 2025. How to do so? By hydrogen, by renewables, by demand response scheme, by PVs and wind power. So a very complex also system to manage. Robinson project, one of the last. I'm approaching the end of my presentation. As a crucial point in the energy management system and in different renewable energy sources, focusing as well on biomass and wastewater valorization. And it is one of the projects where industry is really one of the key topic, because we are used to think often, not always, but as island as location for holidays, nice location for spending our free time. But in and I'm fully on this side as well. But indeed, there are many islands that don't live out of tourism and has very different economies that are focused on industry, and that they should not be neglected. And we don't strive for having just tourism on island, which is an economy model, but not the best one just for island. Then Mesha project is very different, as the focus is on an island which is not in the European continent, and it's close to Africa, and has very different, both problematic and opportunities. It is close to Madagascar, and deploying RES, they are having already some different problems related to how to manage them, to the kind of grid which was designed not in a, let's say, modern way, and it's also very linked to the cultural perspective of this island. Finally, the last project that, let's say, participated to the event today is NESOI, and it's a completely different project, because while the objective is similar, or that is to say, to support the energy transition and the financing of energy transition more in particular, there are in the other project, there were islands already selected in the proposal phase and identified for implementing the innovation and so on. On the other hand, NESOI once asked for islands and project to support, to come to NESOI with proposal, and then is helping. Now we are in the technical assistance phase, the implementation on many different projects from the technical perspective. So I would like to thank you for your attention, and now I would leave the word to our first speaker, which is Nikos. Would you prefer to share your screen or to?
Yes, Francesco. Give me 1 second, I will share my screen. So I guess you can see it, right?
Yes, we can. Virtually, we can.
Okay, perfect. Thank you very much, Francesco. Thank you all for joining. Good afternoon. So the scope of this presentation is to present more or less the outcomes of this workshop that has been organized by IRENA, bridging together 5 European projects, which you may see here in yellow cycles, and mainly deals with the demand-side management, flexibility, and energy management aspects that all these 5 projects are dealing. So the first question that we needed to answer, and so that we know exactly the background of this workshop, had to do with the selection of European islands to act as demo sites for the demonstration of demand, the flexibility, and demand-side management techniques. One of the key issues that should be considered for the islands is that compared to mainland areas, they display much greater seasonality in energy demand, especially during summer period, while local production of electricity, especially through fossil fuels, as in most of the cases, is related to higher costs and therefore as well bigger environmental impact. One additional aspect that all these projects try to address is how these islandic grids will deal with the rapid renewable energy source penetration in their energy mixture, so that they can also account for balancing between supply and demand. And this is a special challenge for the case of non-interconnected with mainland islands, while in the case of interconnected, things are much, I would say, easier to be resolved. In general, why all these projects selected islands to be the demo sites rather than mainland deals with the fact that, first of all, 3.5% of European population resides in islands, while any decarbonization measures are more easy to understand and tangible when it comes down to quantification of the expected impact. In addition, the relevant energy systems that are deployed in Atlantic conditions are less complicated than in mainland, owed to their, let's say, individuality. So most of the islands operate in an autonomous way, while it is easier to set up local energy communities, again, compared to mainland use cases. In this slide, you may see the 5 projects that have contributed in this workshop dealing with demand-side management, and each one, of course, presents a different level of maturity. As Francesco mentioned, SMILE is a project that is close to its end, while, for example, IANOS is a project that has very recently started, last 9 months, more or less. And all of these projects demonstrate solutions dealing with demand-side management, but each one, at the same time, have some differences. So the scope of this presentation is more or less to wrap up the similarities and the differences between these projects. In order for someone to follow this presentation, I would say, in a more structured way, what we try to do is to depict and present the results about the various challenges faced by these projects following the smart grid architectural model. So the following slides refer to similarities that all these projects present relevant to interoperability, communication layer, and additional ones. Now, concerning interoperability, for sure, it is one of the major challenges that most, I would say, projects, European funded, are facing. And there is a clear need for standardized interfaces for best power production systems, flexibility, and one very simple example of demand-side management deals with the introduction of electric vehicles and storage system, mainly batteries, in the energy grids. One source of demand-side management, providing demand-side flexibility, deals also with the consumers, and any related infrastructure that exists that should be as well interoperable enough deals with the application in smart homes, smart buildings, appliances, since these are the main consumers, either residential or tertiary or even commercial, that enable demand-side flexibility. For all cases, what the projects try to do is to apply standardized interoperability platforms, either being, let's say, edge-based or cloud one. And one of the challenges that at least some of the 5 projects have faced had to do with the quality of service in terms of communication and security protocols. And 2 projects out of them have tried to validate different protocols in laboratory environments. In order to embrace all these aspects relevant to interoperability, different software tools and algorithms have been applied. You may see some bullets related to that, but one common outcome was that most of the projects used harmonized data formats like XML. Concerning communication challenges, in all cases, the different grid assets deployed and demonstrated are connected with smart meters for accessing data directly by multiple actors, while preserving, of course, GDPR rules. In all cases, these sensors are mainly digital ones, and the resiliency of them is a key feature. And on top, except from the classical, let's say, monitoring through sensors, also the controls through actuators is an additional aspect that should be accounted for when especially deals with the whole architecture with virtual power plant operation. So for the case that we have decentralized and distributed systems, the level of control and actuation are very important and has been considered. Again, though multiple tools, algorithms, models have been applied in all these projects, all of them try to enable advanced solutions for the increasing complexity of system development and operation. Most of them, I would say, try to apply innovative data processing architecture, though considering, let's say, interoperability and common architectures and formats exactly to serve the scope of interoperability and also resiliency and sustainability of these communication algorithms and the platforms. One additional aspect is that, common one, is that in all cases, big data analytics platforms are employed so that they can manage the available data and provide services to the end user, either multiple type of end users. And for the case of, especially when it comes down to transactive layer, also blockchain approaches are as well employed. Concerning information management, again, this is a challenge faced by all projects, a common one. And in most of the projects, experimental validation of applied ICT solutions are conducted. What is of interest is that especially one project has worked a lot on, let's say, evaluating the bit rates and the different data types in terms of communication. How fast the information is transported from the edges different assets down to the common cloud platform. Different data exchange frameworks have been tested in all projects or are to be tested, including, let's say, the communication between data hubs and grid hubs, trying at least most of the case to ensure wide access to customers and data sharing among market participants, always with consideration to privacy rules. Related to software tools and algorithms, again, various algorithms and methods are applied, trying to provide a more transparent and timely data access to decision making, especially when it comes down to the DSS system, decision support system, also exploiting new technologies and algorithms dealing with big data and artificial intelligence. Multiple toolkits such as data mining, control, aggregation algorithms, trading, integration, planning tools are applied onto these energy management platforms, also for the case of virtual power plants, also accounting for lately, not all projects, but the most recent one also account for cyber protection measures. Going down to the demand flexibility, multiple DSS algorithms are being applied onto the operating energy management systems of various assets, while most of them exploit and try to identify the potential in both economic and technical terms of second life batteries, especially for small and medium prosumers. Again, multiple software, and through these bullets you may see here, we try to aggregate things that so all projects have similarities. And in most of the cases, several operators are as well accounting, grid operators, either on the high voltage or in the medium or low voltage level. Different market models are tested, aiming always to drive more cost-effective investments in a coordinated approach, while network-constrained market simulation tools are as well tested, mainly, I would say, on the design level rather than on the application level, to unlock the full flexibility potential provided by different parties and different energy networks. So we account not only for the electricity, but also the interaction of electricity with heating or gas networks. So when it comes down to similarities, this figure tries to give an overview of common similarities between projects, both at the component layer, so different technologies. And you may see here some examples that in most of the projects, conventional renewable systems are as well are always accounted. While in terms of flexibility, the standard solutions include heat pumps, electrochemical batteries. In some cases, also we have heat batteries. In two cases, if I remember right, there are electrolyzers and hydrogen storage as an alternative storage system, while also EV chargers and EV vehicles are accounting, so more or less demonstrating the powered mobility concept. In terms of software, as we presented before, there are several similarities. While again, in most of the use cases demonstrated by all projects, mobility of both, let's say, standard EV vehicles are accounted, while there are 2 or 3 projects that deal also with the transportation in seawater, like boats. What makes also important is that, except from the similarities, also differences across projects have been identified, and these are mainly related to the innovative technology in terms of software that are applied. To give you an example, in Janos project, for example, there is the inclusion of an auto-generated high-pressure digester to produce biogas that is injected into the natural grid of one island, while, for example, in the case of SMILE, phase change material thermal batteries are accounted. In the recent projects like Janos or let's say GIFT, there are also very innovative technologies like tidal kites or flywheels, or even individual type of flow battery that is also considered into the demonstration sites. One last point deals also with the inclusion of creation of local energy communities. As you may see, all 5 projects try to account also for this aspect and develop local energy communities in their context. In this table, you may see some reference value to have an overview of sizes and number of buildings and consumers engaged. The very interesting case deals mainly with GIFT, which touches the level, let's say, of industrial sector like fish farms, and Robinson, where, let's say, most part of the local energy community is built around an industry. As an outcome, I would say that the key findings, many key findings have been identified by this workshop. Most of the projects work towards self-organizing into local energy communities. SMILE project, which is the most mature, demonstrates for the 3 islands interoperable platforms, and they present also modularity of the solution, and they exploit the capacity to combine the different technologies across a wide variety of properties. One of the key outcomes of SMILE was that for some solutions, unrealistic level of sizes of equipment was identified for the needs of the grids and based on the consumption profiles for some of the houses. It is an outcome very important that the simpler a solution is designed, the better it is for many purposes. In all projects, special attention to interoperability and replicability, even from the design level, is accounted, while, let's say, real-time optimization or third-party integration is a key issue, as being denoted also by Robson project. As a last slide, I would say that the main conclusions derived from this workshop deal with the fact that digitalization can unleash the full potential of customers having a flexible energy consumption towards contributing to more efficient and sustainable integration of variable renewable technologies. Interoperability is an issue that also is accounted through real-time lab tests. Quality of interconnection data communication is also critical. while bringing on board the DSOs is very challenging. This is something that all projects have mentioned, but really worth, because in the end, without the DSO, you cannot really demonstrate the real operation of all the system and the impact they expect to have. So, as a final thing, I would say that the active participation of consumers is paramount for those technologies to be sustainable and deployed, and in the end, be marketized. So, thank you very much for your attention.
Thank you, Nikos. I think there is a question from Dan or Valentina.
Yes. Thank you very much, Nikos, for your presentation. Just a question from my side. So you mentioned in your presentation that interoperability could be an issue. What are, in your opinion, the perspectives of these projects in terms of replicability?
Yeah, I would say that this is a key question, and all projects have mentioned. This is also in line with European Commission and relevant bridge task force dealing with scalability, replicability analysis of all the solutions deployed. As a matter of fact, as part of this bridge initiative and SRA task force, currently there is an algorithm that is being developed in order to try and quantify the scalability and replicability potential of each solution. Practically speaking, I would say that, as you may have seen, many innovative technologies, like, for example, tidal kites, have been demonstrated. But all these systems are very mature yet, I would say, so that they can be connected and offer services to the grid. So for more standard solutions, except, let's say, the electrochemical batteries, thermal batteries is pivotal. So all these aspects dealing with the connection of all different level of innovation technologies with through smart controllers and actuators is pivotal and should be always accounted, so that we can go from the laboratory environment or even limited space testing to the real life. So interoperability is a key issue. It starts from the hardware itself and the connectors it has, but it also expands very recently also to energy management system and virtual power platforms, especially for the case of distributed renewable sources. So my answer in short words is that it is very important and should be always accounted, even from the design level. Otherwise, we may end to test something that maybe not be ever marketized.
Thank you very much, Nikos. Any further question?
No. No. I can see no question from the audience. No. Yes. No. I can see no other question from the audience nor online, so we can move to the next presentation from Joseph. Would you like to share your screen or for us to do it?
No, I can share it myself. Yes, thank you.
Perfect.
Hope you can see my screen.
Yes, we can.
Okay, perfect. Thank you very much. Okay, first of all, I would like to thank Rina for organizing this very interesting workshop, Nikos for his very interesting presentation as well, and obviously to R2M and the rest of the partners that organized this Sustainable Places 2021 Congress. Thank you very much for counting on us. My name is Josep Mitats. I work on behalf of Veolia, mainly on its business unit in Catalonia, Spain. And I am a member of the project coordination team of Project React. And I will be focusing on the topic of renewables and energy storage systems, on the perspective of them being as key enablers for a sustainable power system. But first of all, and as a first glance on today's topic, we'd like to raise this question to everyone. That is, what are the main challenges regarding geographical islands energy systems? So according to many different authors, for example, Alves et al. And Cross et al., they stated that several studies have been carried out on the increase of RES penetration in islands, including 100% renewable energy systems. And in regard to the increase of this RES penetration in island power systems, a benchmarking of survey of 28 islands was carried out, and it was concluded that interconnection of islands can improve overall cost efficiency and peak shaving through obviously demand-side response strategies. And obviously, energy storage can be useful on islands with high with high share of renewable energy sources. The authors also stated that the modeling of these high renewable energy systems for islands should be further enhanced, and that islands would benefit significantly from being used as international test beds for novel technologies. And in this regard, just not to overextend too much, we've listed here what we believe are the main key points to tackle or barriers to tackle on energy island systems, which is the energy cost overrun, mainly due to the high dependency on mainland energy market and losses during the transport and distribution. The excessive fossil fuel consumption due to a lack of strong generation supply infrastructure and dependency on energy imports. And also these variable load profiles, which mean that significant population fluctuations happen, mainly on these islands that rely on tourist economies, and obviously knowing that there are different market contexts and climate conditions. So we believe that there is a very high need of characterizing and exploiting these islands' renewable energy sources to develop a more sustainable energy model. Just to follow up on this, on the left, you can see most islands or more traditional electrical power systems, which are rather centralized, being based on electrical generation within a small number of large thermal power plants or hydropower plants when available. On top of that, islands usually depend on connections to mainland grids, meaning that supply is far away from home, from island loads. And then that long-distance power transport is incurring significant power losses, as I was saying before, therefore adding additional constraints to the supply and demand balance, and obviously to the overall cost of the energy. Traditional electrical grids are largely centralized and mostly based on this, as I was saying, you can see it on the left, on synchronous generation and turbines, for example. But problems associated with the maintenance of facilities and systems, loss of stability, or nonlinear loads, among others, do highlight the need of this paradigm shift on how grids are structured. These problems, we do believe, that can be minimized while maintaining and even improving the capabilities of the current grids by adding standalone network-based configurations based on microgrids or ever bigger grids concepts, but all according to the smart grids technologies such as distributed generation, power flow control, energy storage system. So you can see on the right picture, this highlights the main benefits of deploying energy storage systems on the future electrical grids, meaning that we can improve this high renewable integration, to provide some electrical system flexibility, increase the reliability and resilience of the system, and obviously optimize the resource utilization of those RES potential. Here we would like to focus on the state of the art, on how renewables and energy storage, mainly energy storage technologies, are seen and exploited right now. As stated before, several studies concluded that large scale deployment of RES and storage assets on geographical islands can bring either economic benefits to contribute to decarbonizing local energy systems and reduce these greenhouse gas emissions. As a matter of fact, this RES generation itself does not fulfill, in most cases, the demand requirements of the end consumers due to its uncertainty, variability, and obviously availability. So therefore, these island energy systems, highly reliant on variable renewable energy, would require many services to be a complete overall energy system. This could be provided by these energy storage systems or a combination of both to provide this, for example, bulk energy services, ancillary services, transmission or distribution infrastructure services, and custom energy management services. And here on the right, you can see benchmarking on the main storage technologies. with their technical parameters and commercial parameters, mainly related to efficiency, the charging and discharging rate maximum and minimum, the depth of discharge, etc. And obviously very important ones related to the storage capex, the operating costs, energy density or power density, and life cycles and so on. And obviously the maturity of the technology to take into account the different uses. In this regard, and following some previous points, a number of island grids are now incorporating energy storage technologies for many different cases. In this regard, and seeking for this big scale integration of variable renewable energy, we must characterize the different energy storage technologies and how they can be used in terms of discharging times, because obviously there are different uses for these energy storage systems, and according to the system power ratings, meaning that we must also take into account how much power can be delivered at a single time, and or for example how much energy can be stored and within which time scale, thus to be effective for a specific application and need. In this left picture, you can see, as I was saying, the system power ratings according to the different discharge times and rated power. And on the right, you can see different or suitability of storage technologies for different applications. In that case, the grid services, the behind-the-meter applications, or even off-grid, in that case, focusing on the island grid and so on. You can see that most of the applications of the lithium-ion batteries are quite fitting on almost every category, but you can also see that more innovative technologies or more recent developed technologies, such as the high temperature sodium-ion technologies or the flux, the flow batteries, are also taking part in this market. I'm not going to overextend as other partners and have already stated some of the main or depicted the main contents of these projects, but we would like to at least highlight the main innovative technologies that are being deployed under the different projects. For example, regarding the Llanos project, which is a project made of 35 partners across 10 European countries, will develop several innovative technologies. For example, a tidal kite, meaning that they will profit from tidal and oceanic kinetic energy, an autogenerative high-pressure digester to generate methane, a combination of PV panels with microinverters, a phase change material thermal storage combined, a battery energy storage system sodium-ion based, a grid-scale flywheel, and a hybrid transformer for medium voltage and low voltage substations. And as a software innovation potential, they're going to develop an AI-based virtual power plant. And in that case, the expected results are focusing on, obviously, the increased RES penetration to reduce fossil fuel consumption and reduce GHG emissions on different scales and grades depending on the technology. For example, regarding this, the NESOI project, another one that has already been explained a little bit in before, we can see that as a hardware technology is being deployed, we will have PV panels and inverters with lithium-ion FLP battery energy storage systems and EV charging stations, all of it combined with a big data platform for feeding what they will develop and seen as a very innovative potential, the investment planning tool, and testing through a virtual power plant with the same expected results and impacts as before, now focusing on increasing the RES electric vehicle charging power, increase self-sufficiency rates, reduce power losses, etc. In that case, we have different use cases, and as you can see here, they kind of handle different perspective, all of them focusing on this energy transition towards a much more RES-based renewable energy system. Regarding the Robinson project, they are much focusing on the development, integration, and demonstration of a flexible gas turbine-based combined heat and power unit. This will be also combined with an anaerobic digestion system assisted by bioelectrochemical unit. In that case, generating biomethane or biogas as well, a power to hydrogen unit, and a novel wind turbine as well. And in that case, they also want to validate a modular and flexible energy management system to being able to monitor and track the control capabilities of all those systems. Regarding the Mesha project, they will also deploy some battery energy storage systems, still to be defined. The same as the specifications for the power to hydrogen system, since this project started on November 1st on 2020, meaning that this is quite a very young project and it's still on the design and sizing phase. But it combines as well many different topics that we have already seen before on other projects, such as the virtual power plant, community self-consumption, the smart charging of or B2G vehicles, which is also a quite important integration within the transport sector. And again, it includes some innovative proposals with regards to the hydrogen storage units. In that case, a power to hydrogen unit that will be tested for long-term energy storage. Now focusing on the project that we coordinate from Veolia, the REACT project is made up of 25 partners and representing 11 countries. Our project focuses on large-scale deployment of RES and storage assets, but also we would like to focus on deploying a cloud-based ICT platform that allows the integration of many different energy assets, meaning that a valuable outcome of our project would be to have different packages of technology already integrated within this platform, meaning that a whole energy managed system or energy optimizing service, including forecasting services and other core services, will also be relevant or viable for different hardware technologies. In that case, we are developing different battery energy storage systems, meaning lithium, power to hydrogen, pure lead carbon, sodium ion, and standard valve regulated lead acid batteries. And as I was saying before, we would like to develop this ICT platform for providing these analytical services among all the different integrated technologies. And in that case, we also rely on what we expect to have an impact on this whole energy system of our 3 pilot islands and replication plans for 5 another follower islands in terms of energy savings, increased RES penetration. An important one for us is to reduce or defer the DSO requirements, investments in grid reinforcements, meaning that we would like to contribute on a better system operation in terms of electrical grid. That translates to a 20% overall OPEX reduction, and obviously the overall expected decrease of energy cost and GHG emissions. As a comparative to see this overview, as we were saying, among sister project solutions, we see that we all seek for kind of similar concepts, which is the profitable wind, solar, PV, tidal, oceanic, and biomass potential of all islands. Some of them relying on biogas, in that case not being a primary energy source, but a secondary, as they have already experienced an energy conversion. Some of them do rely, for example, Mesha, on big scale PV plants, or even other wind turbine plants, and as the case of Robinson, or even a biomass plant which is already installed there. But mainly, we will all be installing different innovative battery energy storage technologies, thermal storage technologies, hydrogen storage technologies, to be tested among different ICT platforms, so that we can improve, as you can see in this last row, these grid stability issues that we have identified on our different projects, mainly related to this grid stability and safety, power quality, power fluctuation. In some cases, for example, Mesha focuses on the frequency regulation and voltage control. Some of them want to test how this variable renewable energy penetration is done and how could be it done properly. And obviously, among all of them, we would like to increase grid synergies among all these energy grids on the islands, to provide grid supportive and ancillary services when possible, and obviously when the framework allows us to, enhance grid flexibility, and so on, meaning that we will all contribute in some way to enhance and to ease this power flow of the different energy grids. Our key funding so far and expected outcomes, most of the project, as you can see here, are still designing all their renewable and energy storage enabled infrastructure as well as their software, meaning that their ICT platform capabilities and communication and integration activities are still ongoing. But nearly all the projects agree or have found the following statements, meaning that, for example, islands are living lab for the interconnected mainland systems, meaning that they are the perfect demonstration scenario where to deploy these renewables and energy storage technologies and test their integration and interoperability capabilities and features. That we need to develop effective business models for large-scale replication of all these projects' technical proposals, because some of them are dealing with small case scenarios or are focusing on very specific technologies. So we need to be able to replicate it to make this business profitable. There's a need of involving the island TSOs and DSOs because as we were saying before, we need to track and to see the real-time operation of these systems and see how they're performing, if they are performing on the expected way. Also, active involvement of local administrations and authorities, meaning that we also want to provide some lessons learned and some recommendations on regulatory framework conditions that we are facing, and also to have their support in this clean energy transition. And we found out, especially now speaking of the project that I coordinate, which is React, we found out that user engagement and participation of end users is also very important, so that they can take an active part in the energy control loop. And all of that, we believe that will inherently unlock island energy independency potential, because they will ease the deployment of all these RES and storage technologies will ease the path towards the clean energy transition of islands. Last but not least, as a conclusion, how do we plan on achieving this? And as a brief summary of all, how do we plan on achieving island energy independency and self-sufficiency? Well, as you have seen before and all this summary, we believe that H2020 projects constitute a quite valuable testbed for many crucial R&D activities all across Europe, and that the achievement of this clean energy transition moves towards what we believe are four main innovation levels, which is deploying advanced and innovative renewable energy storage technologies, to enable the technology integration and interoperability, to create new synergies among different energy grids among those islands, and obviously to promote user engagement and develop effective business models among all the different projects. Here on the right, for example, on the top right, you can see the figure of the aggregator, which kind of through a central ICT control systems controls the non-dispatchable and dispatchable units as well as the storage units, so that apart from balancing the local supply and demand, they can also feed the grid to provide these services, and obviously integrating forecasting and price services, and obviously providing this power system flexibility that we are seeing on the top right figure. Also including what we will be discussing right after my presentation, which is the sector coupling. And well, just to end by saying that all showcased projects, the technology proposals are very much linked to their specific conditions, meaning that every island has its own climate conditions, its own RES potential, its own market context, regulatory framework conditions, and obviously their specific energy model constraint issues, obviously dedicated or depending on each of the island's context. But what we have seen across our workshop is that a common work plan demonstrating that the potential of large-scale deployment of these renewable and energy storage systems on geographical islands will surely, will probably for sure bring these economic benefits, contribute to the decarbonization of the energy systems, and reduce the GHG emissions. That will be all from my side. Thank you very much for attending this session, and if you have questions, I will try and answer the best way I can. Thank you.
Thank you very much, Joseph. There is one question from the audience already,
sure.
Which is, by the way, our next speaker, which is Alessandra Cuneo. So I will leave her the floor, and then we can also have other question. I don't know, but please, Alessandra.
Yes, Thank you, Francesco, and thank you for the presentation. I have a question to you. I see from your presentation that within the different projects involved in this workshop, all of them deploy different kind of storage in the islands involved in the different project. Based on the discussion and activities ongoing, have you identified a type of storage that maybe have higher potentiality to be deployed and installed in South Africa Island or not? So the type of storage depends, of course, on the needs and constraints and the characteristic of the island itself, or do you think there is one that maybe will have more potentiality in the future?
Yes, thank you for your question. What I believe, or at least for our experience here on mainly on the React and other projects that we coordinate among storage technologies, we believe that battery energy storage systems among the small scale users would be one of the key points to tackle, because as we know, the prosumer category is now kicking high on many of these microgrid and overall electrical mainly energy systems. So we believe that, for example, behind the meter batteries, for example, we are testing the capabilities of the sodium ion and new approaches on the flow batteries and developments regarding the lithium ones are what we believe would be the best option, or what we need to tackle right now, because larger scale deployment of energy storage systems is now taking place and is already profitable. But at a small scale scenario, looking at the commercial or residential scale, is still pending on some extra research to lower the OPEX and CAPEX of these systems, and we believe that this is something that we need to tackle right now, and that it has a lot of potential to increase the grid stability, as long as these prosumers do have the capability to buy and to integrate these small scale energy storage systems on their microgrids.
Thank you. So I don't know if there are any questions from the audience also here. Okay, so I can start with my presentation.
Great, thanks.
Yes, Alessandra. So now we can see your name is Francesco Peccianti, but you are Alessandra Cuneo from the RINA Consulting. She is substituting the speakers that we have assigned to this speech related to sector coupling. So thank you, Alessandra, for being here. And also thank you, Joseph, for your interesting presentation. So now we can start. The floor is yours, Alessandra. Thank you very much.
Thank you, Valentina. And thank you for actually giving me the opportunity to present in this workshop. Okay, I will try to share the screen. And okay, perfect. So my presentation today. Oh, okay. So my presentation of today is related to the sector coupling and how this could be deployed, and which are the potentiality of sector coupling applied to the geographical islands. Just a brief overview of what sector coupling is. So in general, with sector coupling, we use it as a term that let's say is strictly related to the decarbonization of energy system, and it refers to the interconnection of different energy sectors. So we are talking about the electricity sector, the buildings, so the heating and the cooling demand, the transport, and the industry, which aim is to increase the self-dependency of the grids, to able to increase the renewable share in the grids, in the architecture, and strictly related, of course, to what has been presented during the first presentation on demand side, on demand response. And of course, the sector coupling dealing with different approaches for the load balancing related to the battery storage technologies that are strictly related to the previous presentation. Okay, sorry. So which is the motivation of the sector coupling? Basically is related to the fact that we most of all already know that we are moving from a centralized energy system where there is big utility that produce energy that is distributed to the grid, to the end users. We are moving to a decentralized energy system, and specifically at low voltage, where through the uptake of the smart grids, the energy is not anymore distributed at central level, but we have distributed energy generation sources, and specifically on the increase of renewable energy sources and PV production. And we have a continuous exchange of energy between the grids and the users, also towards the fact that the citizens now are not passive entity that just receive energy from the grid, but they are taking an active role in the energy system, becoming a prosumer, so are entity that produce the electricity also and put into the grid. Okay, and this is strictly related on the next slide, so anticipate a little bit within the sector coupling, but in general, in the new energy system, the role of the citizen is really important, because at the end, the citizen can have an important role that can be autonomous on the production, on the consumption, and on the selling of the energy. So they are strictly related to all the phase related to the production, consumption, and management of the energy into the grid. Going a little bit more in detail on the sector coupling applied to some of the projects involved in this series of workshop, and specifically on SMILE project, where one of the key objectives was to facilitate the increasing of renewable energy generation and consumption. Demand side management strategy and demand side management tool has been developed, which is an important aspect for interface between the different energy sector involved in the Iceland related to SMILE. So we are dealing with the electricity, the transport, and the heating sector, but of course there is the need of enabling technology for the sector integration and for the sector coupling, which in this case in SMILE were related to battery energy storage system with PCM-based thermal battery, but not only at hardware level, but we need also technology from the software point of view. So we need system for the proper management of the energy, and we need load controlled aggregator platform and algorithms for the management of the electrical vehicles. This is, let's say, a structure of the energy management system related to the Madeira demo site, the Madeira Island, actually, that involve the EV charging control mechanism, but also energy storage system that, for one point of view, can enable the load leveling and the peak shaving at the substation, but as well as the deployment and introduction of energy storage system could also improve the self-consumption of the island itself. A second example coming from GIFT project. Again, here we are talking about a platform for the management and the optimization of the different assets within the islands. Here the main aspect that I would like to focus on is related to the flexibility part. So the different assets that are present on the island could help and increase the flexibility of the grids. Assets that are related to the electrical vehicle, of course, but also specifically, it's an important aspect in Iceland is related to the harbor and the ships. So the ferry can be one of an important assets to be considered in this sector coupling approach to be included in our energy management system. And of course, the industry, because we are used to talk about sector coupling and sector integration at residential level, but also the industry through the continuous increase of the electrification of the different sector could be an important point to be taken into account and can provide flexibility to the grid. Again, that's more or less what I already anticipate. So the fact that the electrification is accelerating, the marine sector could provide an important contribution to the sector integration, also because if we are talking about ferry, we know when they need to be full charge. If we are talking about electrical ferry, of course, we need when they need to be charged for shipping to transport the tourists from one place to another. And we also we have the time plan, and in general they are big loads, so they can really have an impact on the sector coupling optimization. And of course, it's important, let's say, to it could be easy to estimate which are the consumption profiles, so the energy profile can be planned easily. And this is the structure of the energy management system developed within GIFT related to the Iceland, which is based in Norway. And again, what it will be one of the main important results is related to the use of the e-ferry as a flexibility asset, which is of course related to the different other system and assets present on the islands. The third example is related to the Insulae project and specifically to the Unie island, which is actually a very small island with specific characteristics and needs. Here, innovation and the solution that are currently under implementation are related to the implementation of renewable energy sources or sources linked to the storage, which is strictly related to the previous presentation, and the fact that in this island, they are also focusing on the control of the water network, which could be another flexibility, let's say, asset to be considered in a sector integration approach. So the fact that the water network could be used as a flexibility asset for the islands, and the fact that within Unie, we the project actually is going to also empower the energy community within the island. So this is more or less, again, the platform that is developed within the project, the Smart Iceland platform that have the aim to maximize the local renewable self-consumption and the creation of the local energy market, also with a focus, again, on the water aspect. And it's important the consideration within the optimization phase of the tourist presence, because of course the dynamics of the arrival and of the departure of the guests in an island can contribute in a significant way to the demand and the consumption. So if we are able to properly planning and forecast the presence of the tourists, we can significantly contribute to a better planning and the use of which are the resources of the islands. So just as a brief recap of the presentation and the different outcomes that came through the experience from the different projects is that the sector integration can be realized in different forms, which depends on the characteristic of the geographical islands, as well as according to which are the available assets. If there is the water nectar, if we have the possibility to increase the electrical vehicle in the island, if we have other kind of assets already installed or that could be installed. So there is the importance of mapping. So it's important to mapping the initial situation of the island and to understand which is the goal of the island. So if we would like to increase the self-dependency, if we are going to if the main aim is the decarbonization of the island, and of course aspects related to the security of supply are really important, because with the island we could have problem with the supply of the electricity from the mainland, so we need to take into account. And of course, all these aspects are strictly related also to the cybersecurity and data availability, because we have seen from the different projects that all of them are related to ICT platforms. So the data availability, data security, it's an important aspect to be taken into account, which is quite similar to also Energy Island on the mainland. So as a conclusion, also the storage have an important role in a sector coupling. For many of us, maybe the power quality is a given fact, but it's not always assured in Iceland or in weaker grids with a high percentage of renewable energy sources, which are an important point for the Iceland. And effectively, the storage could be the bridge among the different energy vectors. So through the storage, through power tweak solution, we can convert the electricity in another vector that maybe could be easier to be managed and to be stored in the island. And in general, which is mainly related to, let's say, the sector coupling as a whole, is that it has a lot of pro. So we can try to enhance the use of the local resources, and we can easily integrate renewable energy sources. We have a diversified energy mix on the island, which is strictly important, and we can foster the e-mobility and the active participation. However, if we are going to integrate different energy vectors, we have a complex system to be considered, to be managed, to be controlled, because we are not talking anymore about one single sector. So we are not talking about just management and control the electricity network, but we need to manage and control the electricity network, which is linked to the district, to the heating network, to the transport network, etc. So it's more complex, it's management. And of course, it's complex also, it's planning during the planning phase. So thanks for the attention, and I'm available for any question.
Gianni, sorry, you're muted. We cannot hear you.
Sorry, Gianni, we cannot hear you. I see your microphone seems mute. No, we cannot or try to write the question on the chat, maybe. I think there is some problem with your microphone. You should unmute yourself. Oh. Okay.
Try to unmute.
No. Maybe we can skip to the next presentation and come back to the question at the end of the workshop. I don't know which will be the next presenter, Valentina.
Yes, of course. I think Gianni. Okay, we can skip to the next one. The next presentation is made by Romain Moget. Hi, Romain. So thank you, Alessandra.
Yes, hi.
Thank you, Alessandra, for your presentation. Thank you very much.
Thank you.
Oh, maybe Gianni can.
Oh, I try.
Okay, we can.
Okay. But
now we can hear you.
okay, I had to exit. Okay, Alessandra, thank you very much, first of all, for your ability to replace last minute the original speaker. And just a very brief question. So we'll talk later about energy communities, but what's the role with respect to the sector coupling?
Okay, yes. Thanks for the question, John. For sure, let's say if we consider energy community, actually there is a group of people that would like to manage to produce and consume their energy itself, so try to decrease their dependence to the national grids. So nowadays, most of the energy community are related to maybe sharing the energy coming from photovoltaic panels, so they are mainly related to the electricity sector. However, if I'm thinking to the future, the sector integration and the sector capping will be a fundamental point to be considered when we are going to create an energy community. Specifically, if we are not talking about energy community of small people in a road or in a neighborhood, if we are considering a larger energy community which involve different users, but also different energy utility, the sector coupling will be fundamental for its management.
Thank you very much.
Thank you.
Thank you, Alessandra. So if there are no questions from the audience in the room, no? Okay, we can go on. Thank you very much, Alessandra. So welcome, Romain Moget from University of Groningen. The floor is yours. Thank you very much.
Can you see my screen?
Yes, we can.
Is it in slideshow? In full screen?
It's not in full screen mode. So maybe, okay, try again.
No?
Not yet.
1 second then.
Okay.
I will try to share my entire screen. I think it works better.
Yeah, it's better.
Yes. Then, in principle, now it should. 1 second. Now it should work.
Okay.
Can you confirm?
Yes. Thank you.
Thank you very much. So, thank you very much first for giving me the opportunity to present some of the feedback and results from 4 out of these various projects dealing with Iceland and being funded by the Horizon 2020 program. I will focus in this presentation specifically on 4 projects that you have already been hearing about: Smile, Gift, Robinson, and Mesha. And I will, of course, focus on the regulatory framework, and I will provide some examples about energy communities. These are common points that we could find between the different projects. So as we have seen over the 3 past presentations, for the energy transition in general, as well as on the islands, most of the technologies are already here. Of course, they are still having to make progress, which is happening, but we already have actually quite a vast array of technologies in terms of generation, consumption, storage, IT, etc., etc. We have the economics that are increasingly in favor of these new systems, with as well renewable energy generation, IT systems, and for example, storage technologies that see the prices getting lower and lower all the time. Now, what is missing in many cases is actually an adapted legal framework to organize this transition and to really harvest these technologies. And here we use this example of energy communities. Why? Because they constitute a platform that allow us to unlock local generation and local flexibility, to potentially accelerate the transition, to facilitate its acceptability by the local communities. Sorry. And it is especially relevant now that we actually have an adapted legal framework that is appearing at EU level now for 2 years for the 2019 Electricity Directive and the 2018 Renewable Energy Directive. However, there is still, as we will see in detail, more detail, lots of work in terms of implementing it at a national and local level. So to provide first a brief overview of the legal regime that first applies directly to Iceland in EU law. Well, you will find in the 2019 Electricity Market Directive, first of all in Article 2, 42 and 43, the definitions of small isolated systems and small connected systems, which are two regimes which could be actually granted by member states requiring it to the European Commission, and they could then get exemptions from the classic rules of the liberalized market. These are the articles that I just mentioned below. However, this can really give large and I would say deep exemptions from the liberalized market, such as having integrated energy companies that are dealing from production to consume to supply, with the distribution and transportation in between. So this is mostly reserved for really non-interconnected islands, such as in the case of the SMILE project, Madeira. So this is quite a limited regime, and on most islands in the EU, actually, the classic EU law applies, the same one as on the mainland. Now, in terms of the energy communities, you can find here as well the provisions with the definition and the regime for citizen energy communities that are more limited to electricity, and renewable energy communities which can use different energy vectors, but always using renewable energy. These are new regimes, and they, above everything else, open a lot of opportunities in what can be done. And these regimes now provide such a level of legal certainty, in which case they can really play a major role to facilitate the transition on islands, depending on the national transposition, right? Very quickly about the projects that I will compare here, I will be talking about. So on SMILE, we have 3 demo sites in the UK, in Denmark, and in Portugal. In Mesha, this is 1 demo site in France. In Robinson, that's 1 in Norway, and in Gift, it's in Italy and in Norway. As you can imagine, while technologies can actually be applied pretty much everywhere with some modifications, sometimes needed, the legal framework just changes with all countries. Even within the EU, where we have a level of harmonization, the implementation differs from member state to member state. So that's important to keep that in mind, that in law, all these cases will be different. Now, entering into the research that has been done for these different projects, sorry. First of all, in the SMILE project, we had a dedicated study of the applicable legal frameworks for 4 main aspects: electricity storage, electricity and heat supply systems, microgrids, and the balancing of local grids. The main outcomes in this case is that the EU legal framework, especially the directives I have just mentioned before, Electricity Directive and RES Directive, has developed a regime for energy storage and for the evolution of balancing markets and the creation of local flexibility markets. So that's really a plus in terms of what can be done to provide clarity to the different actors, especially, but not only on islands, especially in the case of energy storage, which was the topic of the first presentation and was just mentioned right before. So for this, we have a level of legal certainty, although, of course, the national transposition is still lagging behind in some of the member states, right? However, the appropriate legal framework is more scarce in terms of the power to heat, which is normal because heat is not really being legislated on at EU level. It is much more an issue of national legal frameworks. So that's normal that when you have this sector of heat, then you have to really see what is the national legal framework more than at the EU level. Only a few broad rules are provided. And in terms of the microgrids, which were also one of the topics of study, then there is almost nothing really on the concept of microgrids, which does not mean that one can use, for example, energy communities to create kind of as a proxy, a specific type of microgrid. But the term microgrid does not appear in the legislation, and there is no specific regime for this. So what is missing is, especially for providing more detail for the local flexibility markets, but also, for example, for microgrids with the question of, is it possible to Iceland or not your local grid? What is missing is an update of the network codes, and in general, for all these topics, a detailed national transposition. In the case of Mesha, it's quite different from the case of study in SMILE, because the most important aspect is that there is a very difficult local social context, with half the population being less than 18 years old, more than 25% of unemployed people with official statistics, half of the population with no legal status on Mayotte, 30% of the population has no or insufficient access to running water and or energy, and the list goes on. And in this case, they have tried to actually develop energy communities as an opportunity for the transition and to try to tackle some of these social issues. And this, through this project and with this final goal, they have been developing financing schemes and business models. So of course, this rely on the appropriate legal framework as well. And they have been trying to develop public-private partnerships for energy communities and building upon multi-stakeholder governance. In the end, this development and this use of the energy communities, which have been transposed in French law also quite at a basic level, could allow energy access, to reinforce energy access, but also to demonstrate some innovative technologies, such as power to hydrogen to power. In the case of Robinson, so that had one island as a demo site in Norway, the idea is to decarbonize industrial islands through the smart integration of multiple energy vectors, electricity, heat, and gas. So this is typically about sector coupling that we have just heard about the more technical aspects right before. In this case, we also are facing legal issues, and the main one is that different rules and regulations actually apply for electrical, thermal, and gas-based energy production and exchange. In addition to this, you have different actors that are playing a role for each of these systems, the DSO for electricity, the district heating network operator for the thermal system, and so on, and there are different tax regimes. So that's really a barrier in the sense that it causes to lose actually quite some time to figure out what's the regime in each sector and to try to have all the authorizations right together in terms of getting it running and then for operating it. In the end, it's easier in technical terms to have sector couplings than in legal terms. They are also developing their energy communities, and the main issue that they faced is that it was difficult to match all the actors that are present locally, all the actors' interests and plans. Of course, there are industries, there are also neighbors, so there were some issues with the potential wind turbine, etc., etc. So this really shows that every case is different. If you have the legal framework, it allows you to do some things, but then after on the ground for the implementation, it will all depend on this kind of negotiations. In the GIFT project, they are trying out a smart, flexible system with demand response, prosumers, storage, etc., etc. And it's also in Norway, where they have two demo sites, but the main one currently is in Norway. And the main issue is low electricity prices, and that it's already quite green in a sense. It comes at 19% from RES. So that's an economic issue, but actually that's an issue on which the legal framework can have quite a strong influence. For example, this has been shown when the new grid tariff model has been adopted and is implemented since this year. And this new grid tariff model is actually calculated on the highest peak of consumption. So if you have your peak of consumption as, I don't know, whatever, 50 kilowatts, then you will have this tariff at this level for the whole day. This therefore provides an incentive to lower peak consumption through flexibility. And this is how with the legal framework you can actually really impact and spur a change in energy use by the people, right? The first results are that there's a lack of business model for prosumers, energy communities, and for batteries. And the definition and concept of energy community is still immature in this part of the north of Norway, but it will be an indicator and an upcoming topic due to this recent regulatory change. If we compare in a table these different developments among the 4 projects, we can see that in the first case of SMILE, so the general framework at EU level is okay. Now it's really about the details, the network codes. There's actually a new one that is being drafted by the at EU level on demand side flexibility. For example, that's a good opportunity to incorporate these new technologies and the new uses, the new activities into the legal framework at EU level, but also in terms of project requirements for flexibility markets. Are they actually fit for purpose in terms of the small actors? Can they access and propose such products on the local flexibility markets? Currently, that's quite difficult. Usually the barrier, the threshold is quite high in terms of local, small integrated actors. The national regime is also, of course, to be developed in detail in terms of the transpositions, the taxation, etc. In Mesha, so as said, there is a basic national regime for communities that is already in place, but there are many broader issues that are more actually social issues, even, for example, unclear property rights. In such cases, that's, well, it's not only an issue of energy law and energy technologies, it's really about negotiating and problem solving, really problem by problem, right? Energy communities, however, can be used as a vehicle for involving people and to tackle social issues such as the problem of energy access. In Robinson, as I've hinted towards, an integrated permitting and/or management regime for multiple energy vectors could be quite helpful in terms of simplifying the development of sector coupling. And we have also seen that a negotiated approach to satisfy all the actors is needed. It has worked in the sense that they have already started to actually attract interest from other industries on the islands and from other islands via what they have already implemented on the ground. And there are also the new tariffs that have been implemented in Norway that are tackling also this issue of the very low electricity price so far. And in the GIFT project, well, there are economic and legal barriers that were quite strong at the start in order to attract interest in energy communities, but this new regulation I just mentioned now actually has increased local interest. So as a few last key points and as a conclusion, we can see that the EU legal framework has really made great steps to accelerate the transition, to provide a framework, including, but not only, on Iceland. Now it covers most of the technologies that are used typically in these projects: storage, demand response, local flexibility markets, etc. And it provides legal certainty. However, the national transposition really takes time, and some member states also experience delays in this transposition, and they don't all do this with enough level of detail to really have a good and adapted legal framework. And it really differs per country, as we have seen, for example, for energy communities are developed in a different way in all these countries. And the devil is really in the details, in the network codes, in the product requirements, in all these tiny gritty details. But overall, maybe it is a bit obvious to say that, but these projects really show that the legal framework can be either a barrier or an accelerator for the energy transition. For example, this change in grid types regime in Norway really shows that it's like day and night in terms of the interest of the people for developing such infrastructures. That's it for me. Thank you very much for your attention, and I would welcome any question.
Thank you, Romain. Thank you very much.
Thank you, Romain. Can you hear me?
Yes.
Okay, thank you very much for your presentation. Just a couple of questions. So you have mentioned in your presentation microgrids and local flexibility markets on the Smile Islands. Can you detail a little bit more the existing local regulatory barriers?
Yeah, well, what's very interesting in terms of the local flexibility markets, especially, is that for the SMILE countries, the one that is the most advanced is the one that has been leaving the EU, it's the UK. Well, probably because of their local context, also with many islands as well, and being itself an island, they have quite a high need for flexibility because otherwise they rely a lot as well on interconnections with the continent. So they have been developing it, and very interestingly, they have been developing, for example, some local flexibility markets managed by DSOs, where the entrance ticket, the minimum bid size was at only 100 kilowatts, which is quite low and which is very good in comparison to what we see for other kinds of markets, for example, the balancing market, which usually requires 1 megawatt. And 1 megawatt is completely out of reach for small communities, such as the islands that we have seen. In terms of flexible capacity that we are trying out, it's not being reached currently by any of the islands that we have seen. So I think that's the most important development to happen now in the EU. So in our case, in Denmark and in Portugal, but also in other countries, is to facilitate this implementation. And this is required by the directive, actually, for DSOs to organize these markets in order to procure flexibility services for their needs. So they will have to do this more and more, but for the moment, it's still really nascent on countries that are not the UK.
Okay, and very quick questions. Could you provide us some more detail on the taxation issues that you mentioned before?
Yeah, indeed. This also, depends, varies really with the country. That's definitely a national competence. And we have seen as well in SMILE this difference playing out. For example, the system has been dimensioned in SAMSE really is impacted by the taxation, because they have in Denmark a very high level. I think it's 50% of the bill is basically taxes. Therefore, they have tried to have a system where they would inject as reduced as possible amount of electricity into the grid. They really prefer to self-consume. In other cases, it will be a different system. Now, there is interest as well of having quite a level of autonomy in having your own infrastructure with its self-consumption, but it also means that, therefore, they are not really incentivized, for example, to provide flexibility services to the grid. So this is really in terms of the pros and cons of what you can do actually with the tax system, and potentially what you can develop in terms of incentives for small actors, such as prosumers or such as actors on islands or islands themselves, to provide such kind of services and facilitate the transition. That's really a tool to be adapted for the current needs.
Thank you very much. Thank you.
Thank you very much.
Thank you very much, Romain. Thank you. So now I give the floor to Alessandra Montanelli from SILDOC. Alessandra.
Thank you. Thank you, Valentina. Yes, I'm sharing.
Try to share the screen if you. Okay, can you?
Yes. I guess you can see it.
Okay, perfect. Thanks.
Okay, it works. So thank you, Valentina, for the introduction, and thank you to the R2M and the RINA colleagues for organizing such an interesting workshop. So today I'll talk about the NESOI, the European Island Facility, which is an Horizon 2020 project funded a couple of years ago, and with the aim to support European islands' energy transition process, facilitating the decentralization of energy systems and contributing to European policy to achieve the 2030 targets. Actually, as also mentioned in the introduction, NESOI is a pretty unique project since we are a technical assistance platform. So we are deploying consultancy services to support feasible projects towards their implementation and facilitating also the access to finance. We're now supporting more than 40 initiatives, and we target to reach our objective of 60 after the second call to be launched in a month. So selected islands are benefiting from NESOI of a specific project structuring technical assistance provided directly by our professionals, which is also being complemented by local contractors, which are financed with also our grant resources. So as a whole, beneficiaries are being provided with more than 6 million euros of activities and direct resources. But which is the framework and why the European Commission and DG Ener actually created a technical assistance platform? So the European Union, as mentioned also in the previous presentation, is setting a clear path towards energy transition, which shall involve actors and players in different sectors, and each member state has its own contribution in the process. Of course, locally, public authorities have been working on planning documents for energy transition, of course, and now is the right moment to turn these plans into concrete initiatives to promote energy self-reliance and reduce the dependence from fossil fuel. Of course, in this framework, finance has a key role, and it is actually a challenge on the one hand, but also on the other is a great opportunity if we take into consideration the wide range of available dedicated financial solutions to foster energy transition investments, including also the new multi-annual financial framework, but also the Next Generation EU. So according to our experience, currently energy transition projects can benefit from an increasing broad set of technological solutions, mainly consolidated and known to the market players. There are also methodologies and analytical tools and processes which are tested and very useful for the evaluation, the structures, and the implementation of projects. And also there are public procurement procedures and practices which are consolidated, and also contractual agreements which are mature on the market. So the potential for investments is actually huge, and this is can be also observed by the very good results achieved by projects supported by, for example, the European Investment Bank Elena schemes, but also the Jessica funds. Nevertheless, the uptake of these solutions is still limited when compared with the potential that they offer. And this is even more true in fragile contexts as islands, where a number of factors hinder the successful activation of potential solutions. So typically, critical aspects include project fragmentation and low unitary cost of technologies to reach an adequate critical mass, but also the lack of coordination among local authority and the absence of synergies for a common management of projects. Generally speaking, local authority used to lack also human resources or however adequate staff with specific knowledge of funding opportunities, but also technical skills, for example, engineering, legal, economic, and financial competencies. So this makes the project development even more complex in such context. And this is also linked with the missed use of best practices already developed in similar contexts. Finally, also governance is an issue, in particular the governance instability. Since energy transition projects are medium-term projects, they often exceed the political mandates, and this could be an issue because this can lead to a high variation in the project contact persons and in a general absence of political and managerial leadership for the projects. So if we take this into consideration, altogether this barrier may lead to project not being launched or being unsuccessful. From a financial point of view, resources are there, so funds are actually available, and what is the issue here is that project needs to be well defined and designed to access such opportunities. For this reason, and for the barriers I have mentioned, financing local energy development projects may be complex, maybe a complex process, especially in the energy and renewable sector. So besides traditional financing, now we have a very big opportunity, and a big variety of solution is currently available. This is true if we talk about traditional financing schemes, but we also have some new instruments, for example, under the multi-annual financial framework, the Next Generation EU, but also we have innovative instruments such as the crowdfunding solutions. So here the issue is blending. Blending is key, meaning we should be able to activate different sources of finance, but this should be the result of a smart and focused analysis of the opportunities which are currently available. And in this sense, technical assistance is a key tool to achieve such objective. So starting from this, the Nazai solution provides islands with a tailored support, combining a team of experts with some local advisors, so a local team. In this way, we're able to provide technical, economic, and financial, but also legal and procedural support, ensuring on-site technical assistance and leveraging on partners' track record, but also on the local knowledge. More in detail, NESOI is meant to provide on-site and tailored technical assistance to projects to selected islands. As we know, the COVID-19 has, of course, limited our travels, but NESOI support is meant to be very island-oriented, and hopefully soon we could be back on the islands to provide our assistance. I mentioned also partners' track record. We are a consortium of 10 different companies with operation in many countries in Europe. We have a solid expertise in the sector and in providing advisory services to our clients. In addition, we can ensure a 360-degree support, having on board engineers, economists, but also lawyers. And last but not least, the local knowledge. NESOI is based on a collaborative approach with these selected local advisors. And in this way, we can also leverage on the knowledge of the local context, of its criticalities, but also opportunities that only the local community can fully understand and effectively manage. So this is our solution. And we are very proud of the result we got so far. So these are the results of the first call. Last year, we have issued our first call for proposals, and more than 100 applications were submitted. We were able to finance 28 projects and create also a reserve list from which we are now going to activate additional 40 initiatives in the coming weeks. So, and now we are managing 42 projects in 50 different islands in 11 countries. And according to the expectation, these initiatives could trigger more than 1 billion euro of investments by 2023 in energy transition projects. We have allocated more than 2 million euro of direct funding, and an equal amount of activities has been provided by the partners or is being provided by the consortium. So projects are now in the first phases, and we are very satisfied with the preliminary results we are achieving. But of course, this is only the beginning. However, we have some lesson learned, which I'm very happy to share with you today. So far, we understood that islands and in general local communities are willing to complete their path towards energy transition. Many islands have already a transition plan, others do not, but the vast majority of the submitted proposals require the support to develop feasibility study and analysis to identify the priorities and the available technical, procedural, and also financial option to realize the initiatives. So this is a very important point, actually. Also, very often islands are organized in small municipalities. Thus, early support is also needed, for example, in the application phase. For this reason, NESOI has implemented many supporting tools and materials to guide the interest applicants also through the submission process. We are going also in this second round, we're going to reactivate our national online help desks. we were very satisfied with the feedbacks we got from round one. Help desk are a place where you can come and ask any question on the call. If you have any doubts, we can help you in clarifying the gray areas. And applicants will also have the guidelines available on our website. There will be also the self-assessment tool, and we're also going to organize some informative workshops. Finally, another interesting finding is that local community engagement is a crucial factor. This has been also mentioned before. This is key for the implementation of projects, and the involvement of the local community, meaning the citizens, but also the decision makers, is very important to ensure the full alignment on the final objectives. So finally, let me go through our calendar. The very good news is that we're going to launch our second call for proposals in about a month. Compared with round one, round two would be more focused on innovation, but each initiative of energy transition, or however meant to foster the decarbonization of islands, is very welcome. As anticipated, we're going to have two webinars, an informative webinars on the 25th of October and a more technical one around mid-November to go actually into the details of the application forms and all the technicalities for the submission. Please consider that the dates may be changed slightly and they need to be confirmed, so you can find the latest updates in our newsletter or however in our website. So make sure to visit also our website to get the latest updates also on this. This is all from my side. If you have any question, I will be happy to answer. Thank you.
Thank you very much, Alessandra, for your presentation. Just a quick question. So, according to the initial experience in the more than 40 NESOI technical assistance projects already started, is there a sound background in the islands on energy transition? I mean, previous project, for instance, previous plans, etc. Or in some case, do you have to start from scratch?
No, actually, what we found out is that many islands have already a transition plan. They have been working on this very well, actually. But now what they are asking is to take this a step forward. So, of course, we are leveraging on this, taking this as a starting point, but our support is mainly oriented to create new priorities and to support islands in understanding which is the action plan basically they need to implement to actually realize their energy transition. So some of them were already well advanced in this process. Others still need some support in the planning phase, but since our support is, as I mentioned, very island-oriented and very tailored, we can support all of them in their transition.
Thank you.
Thank you.
Thank you very much, Alessandra. Thank you all for presenting. Now I'll share your screen and I will start with the roundtable. So let me try to share the presentation. I don't know if you can see my screen perfectly. It's okay. So now we will have at least 20 minutes, 15 minutes to discuss about some topics related to the workshop of today. So thank you for being here. I will just give you the first question I think it's really interesting and important to discuss about, which is related to the actual barriers. So in your opinion, I will maybe start with, I cannot see you because I'm sharing the screen. So I hope that is visible for you. But maybe I will start with Nikos because I know that he is really have short availability of time. But maybe Nikos, if you have an opinion related to which are the actual barriers that limit the clean energy transition of island, and if these are mainly of technical, legal, or economical sources. So maybe you should be the first one who could give your opinion.
Yes, thank you, Valentina. My personal opinion, and based at least on my experience from, I would say, multiple projects, but also business-oriented ones, is that the main barriers deals with legal issues. Most of the technicalities have been resolved or can be resolved. Let's say the main barriers that especially investors face deal with legal and the local regulatory framework, which is not homogeneous, I would say, on a European level. So each country has its own specificities. And this is the main barrier that investments are facing. On top of that, at least in Greece, it is very painful process, the all necessary bureaucracy and papers that need someone to submit in order to get a license for operating renewable sources. So I believe that technicalities can be resolved, if not most of them being resolved already, while economical issues, I think through incentives, are possible to be grounded, let's say. So this is my opinion.
Thank you very much. And so maybe I also give the floor to Joseph, if he's still be connected with us.
Yes.
And Joseph, do you have the same opinion, or do you think to add something more with respect to Nikos?
Well, I completely agree with Nikos, because on my experience, not only on European projects, but our technical bureau here in Spain is dealing very much with regulatory and framework limitations or constraints while trying to exploit or to operate many different water, waste, or energy plants. So in this regard, I believe that the technology solutions are quite developed, meaning that we can offer our clients, for example, as an ESCO, different kinds of service provisions regarding different technology solutions. So meaning that all the problems that they have, they can be solved in a quite an efficient way. But we are facing much troubles while trying to operate. For example, we're now dealing with a significant trouble while trying to re-engage a cogeneration engine with a significant study of a life cycle analysis and environmental impact analysis, which is quite beneficial not only for the climate but both also for the client. And our main limitations from several months ago is the bureaucracy, as Nikos was saying, to being able to get the permissions to operate this plant within a much better environmental and sustainable way. So yes, I believe that the biggest constraint here is in terms of legal, mainly transposing, as Alessandra was saying, in the same way or in a similar way as Roman was also saying, the European directives on a similar way to all European countries, and well, that's quite a big challenge.
Okay, thank you very much. So Romain, could you add something more related to the legal point of view in this sense?
Yes, well, actually, I already provided my answer in the presentation that I saw that technical and economic issues are, as Nikos has said, or already solved or can be solved relatively easily. And usually what remains as not one main barrier, but as actually various barriers, sometimes small barriers, but getting together are creating big issues. And it's not only that we have now a legal framework at the EU level that recognizes that, for example, energy communities can be set up, but you have all these, as I said, details that are missing and that have to be decided at national level. For example, in terms of legal status, does it have to be an association? Does it have to be a company? What is the regime that will apply? If it's a company, how many people? What's the personal responsibility of these people? Because not everyone is ready to engage its own criminal law responsibility. And we have a host of questions like this. For energy storage, that's the same. You even have hazard or fire regulations that would apply. Sometimes that can represent an issue as well. I'm working as well with a colleague on storage, on can you do actually benefit stacking to sell various different types of storage services. How can you actually do that? Is it authorized? Well, in many network codes, it's not. So indeed, legal issues are for me the main one still on the way to the transition.
Yes. So thank you. And also, I also give the floor to Alessandra Montanelli, who also gave a very good explanation related to NESOI. Would you have the pleasure to add something related to the answer from your colleague?
Yes, actually, I'm very happy with the answers that the colleagues already provided, because I totally agree with them. Regulation is an issue, and in particular, transposition is becoming critical. Now we are, for example, in Italy, facing months of uncertainty due to the transposition of the directive of the energy communities. So we are waiting actually for this to happen. And this, of course, is a very big barrier for investments. As I also mentioned during my presentation, I don't see any economic barrier to energy transition because funds are available. The only issue is to actually structure the initiatives and the projects in such a way to be able to access this finance. But yes, regulation is probably the main barrier here.
Okay, I think so. We can also go on. So once we discuss about barriers, what about the opportunities? So could you provide a good, let's say, point of view related to the opportunities that could boost the clean energy transition of islands? So I don't know, maybe if Nikos is still there, or who wants to reply?
Yes, Valentina.
Okay, thank you.
I believe that the main drivers actually deal with economical aspects. If I take the example of Greece, as you may probably know, now most of the islands are currently being interconnected with the mainland. So any renewable source produced on the islands will not only decrease the cost of electricity, the levelized cost of electricity actually on the islands themselves, but it will be also supporting mainland. So to give you an essence, in Greece, the cost, consumers in the mainland pay almost double price of what they could pay for the electricity owed to the associated costs from islands ones, which means that operation of fossil-based fuels mainly currently in islands almost have a significant impact also on the mainland. So one driver deals with the interconnection and therefore local produced energy in islands, which will also reduce the cost for the mainland. So this is my opinion. If I can add something on the previous question, I would say also that we need to consider for social acceptance. I mean, in islands specifically, social acceptance is an issue. Most islanders are not very fond of big wind turbines, let's say, or big solar parks. So this is something that we need also to have in our minds. Thank you.
Yes. So I think you also anticipated a little bit the next question, but I completely agree. So someone else wants to add something to the Nikos opinion, maybe Joseph, who was again the second speaker.
Yes, in that path, I will also go for, as I was saying, for the technical point of view, because I believe that there is still a lot of potential to decrease the capital expenditures of many technologies. Now focusing again on the topic that I was dealing with, which is the energy storage. I believe that there's quite a good potential, and even Europe is quite focused on hydrogen. On value chain of the hydrogen as an energy vector. So I believe that this could provide also this incentive in terms of technical point of view, and of course as Nikos was saying, there are still some economic and market aspects that still rely on the mainland that could be depicted once the islands can completely depend on their self energy independency. So once these islands can rely on their own energy potential and self sufficiency, I believe that once, as we were saying, the legal constraints are solved, both economical and technical issues will be quite solved within their own energy infrastructures.
Thank you. And also, Alessandra Cuneo, do you have an opinion related to the opportunities in this sense, or you think it's more?
Yeah. So okay, I totally agree of what Nikos said related to the fact that okay, today I learn a lot about Iceland to be honest, but the main opportunity from my point of view is that Iceland have very high potential for renewable energy sources, so deployment of renewable technologies that could boost for sure the energy transition. So we need to push this aspect. And in general, I think that even if social acceptance is not maybe so high at the moment, in general, the community in Iceland are more close each other. And if we are able to perform a good local community engagement on the site, on the field, this could for sure help to exploit the potential of the islands and how Iceland could contribute to the energy transition.
Sure, for sure. Thank you. And also, Alessandra Montanelli, do you want to add something more regarding this?
Yes, thank you. Well, I totally agree on the fact that social acceptance needs to be well evaluated in these processes. What is important here is that solutions and however initiatives for energy transition shouldn't be a top-down approach, a top-down solution, but should be created starting from the bottom, so having also the citizen involved in this process. And a big opportunity here is also in terms of finance, so for innovative schemes such as, for example, crowdfunding, but also what we mentioned before for the energy communities. We have actually a lot of opportunities here, and the issue is try to understand how to keep them together in order to have a final objective, which is the energy transition.
Thank you. Romain, would you add something?
Yes, very quickly. I also see opportunities to be provided now, especially significant opportunities in the finance sector. For example, I was thinking about the recovery package. So basically, there is a lot of money that is to be provided to the member states. So now the idea is how to manage for part of this money actually trickles down towards the islands, no? And not only stays on the mainland. But there is this focus on the islands with this idea of trying to decarbonize 1,000 islands by 2030. So this is really something that if responsible municipalities, etc., that are dealing on the island and have contact with their government, that's really these are arguments in terms of lobbying. But of course, we are more entering into political bargaining, etc. But yeah, there is a lot of money to be provided for that. Even the financial mechanisms for the just transition as well could actually be used as well for the islands, because they usually have higher rates of unemployment or of heat poverty, these kind of issues. So it's also possible to actually have good arguments in addition to the huge potential of renewable energy to manage to get a part of this money and to fast track really the transition.
Okay. Thank you very much. Thank you for your sharing your ideas and your opinions. And so, since we cannot like discriminate between financial, technological, and sometimes also legal strategies with respect to the sociality and also the local communities, how much is important the local engagement? Some of you also already answered to this question. How much is the local engagement relevant to perform the transition towards island decarbonization? So which strategies can be adopted to guarantee a positive social engagement on island? I don't know also if Nikos is still connected, because I know he needs to
I
move.
am still.
Are you still there? Oh, thank you. Thank you very much. So if you want to also to give a really quick answer regarding this, even if you also give us a quick
As I
opinion.
said, local engagement is very important. Now, concerning strategies, I would say that except from standard practices like local engagement activities, presentation and gathering and all these things, it is important for local islanders to see similar systems operating somewhere else outside their territory, so that they can see really in real life that this system operates and presents benefits, to compare what they may have sometimes in their minds. An additional idea would be that having always in the back of my mind the case of Samsung from Smile, which is, let's say, a very well advanced island, European one. Nevertheless, they also counter a lot of problems with social acceptance. I would say that there are many people who present most of the times facts that are not actually grounded on something real. So there is a lot of speculation sometimes for systems that is not does not represent real life. So one strategy could be that after a certain point, technicians and experts give answers as well to those people to explain the ordinary people that they are wrong to what they say with actual facts.
I completely agree. Thank you. Thank you very much. I don't know, also maybe Alessandra Cuneo, who has a really interesting point of view related to local engagement strategies.
Yes.
If you, thank you.
Okay. Yes. So for sure, the local engagement is important, and also if we link it to my previous presentation of sector coupling, the end user actually are now are I say they are no more consumer, but they are becoming a prosumer. So the active involvement it's really important, and from my experience also related to other project on energy island, actually not geographical one, but let's say energy one, but some dynamics are the same. It's important to have a participatory approach and a co-design in the development of the different technologies and solutions that need to be deployed at the island level. And it's important to involve from my point of view, the end users, the citizen during the whole phase. So starting from the design of a new energy system, new technology that will be deployed in the island, but as well as during the, let's say, what we call it in general in the project demonstration phase, and in a continuous approach, sort of circular approach, when the citizens are involved during the planning phase, when we are implementing the solution, but also when the solution are on the field and works, to receive feedback from the citizen, how they work, and maybe modify something or change some strategy or whatever that continues to be aligned with which are the needs and the interesting of the citizens. So a continuous engagement and a continuous discussion with them is important, not just at the planning phase or the design phase, but in a continuous way.
Thank you. Thank you. Completely agree with you and with your point of view. I don't know, maybe also Alessandra Montanelli, what do you think about it from NESOI point of view? So you manage a lot of islands. during the project. So many islands answer to the first call. So
yeah, actually, from our experience, what we can see is that generally speaking, public authorities are mainly the first one involved in energy transitions, but they are trying also to have their community engaged. So they are asking a lot of support also in such activities to have, as I was mentioning before, this kind of bottom-up approach to involve citizens from the very beginning and to make them also aware of the possibilities that actually energy transition can achieve, actually. So what is also very important is to raise awareness around this topic, because often people are pretty scared about what they do not totally can comprehend. So since energy transition could be somehow also difficult to be understood, raising awareness is also a very important moment for the energy transition. And also, so public, in general, public sector has probably a key role also in this.
thank you very much. I don't know, maybe Joseph and Romain, if you have a very quick answer to be added to what the colleague already said.
Go on.
Roman, you want to go first?
Go.
Okay, no, just a brief comment on that, because we have experienced it quite difficulties on this regard. From our experience on the React project, we found a lot of mistrust from the local islanders on with regards to the renewable energy and the storage technologies and on all what kind of follows the energy transition on islands. So I believe that this and some of them did really have poor knowledge on what that is. So maybe we should foster their and make them confident that all of this is useful and is happening, so that they are aware that they can participate, meaning that they need to have some incentives in order to participate in this energy transition, because we faced a lot of mistrust and a lot of misunderstanding on what we were going to do on the island. So I believe that more knowledge and more incentives are needed to engage this and make people participate.
Okay, so Romain, if you...
Yeah, very quickly, then 5 seconds. Yeah, because everything was more or less said, no, that it has to happen from the start and to really involve the people, because if not, you won't manage to actually have a full transition, because maybe you will be able to push for one project without the consent of everyone, but then this won't happen for the next one. So there are many different systems or mechanisms to actually involve people, such as citizens' assemblies or whatever. So you really have a choice in terms of what you can do to involve the people. I think the most important point on the long run is that you are sure, you ensure that you will respect the results. Because if you try to attract the people and talk to them, etc., and after you don't actually follow up on the results, or you do more or less whatever you want, then you will not be able to engage them again in the future, and it will necessarily have an impact on the transition. Yeah.
Thank you very much. Thank all of you for your opinion. I will give the floor to Gianni for the conclusion remarks.
Thank you very much, Valentina. Can you hear me?
Yes, perfect.
But probably we have a couple of minutes, so probably that it doesn't make sense to share also the presentation. I would like just to mention a few things before closing the workshop. So first of all, I would like really to thank all the speakers. And after these 2 hours of presentation, it's clear to everyone the huge amount of work that has done by the rapporteur. Probably the simpler way for organizing this workshop, it would have been just to ask each speaker to present his own project, and then to try to grab during the meeting the main difference among this project. But as you've seen, we have been much more ambitious, and we decided to invite 8 2020 project dealing with energy transition of islands to share their experience in for webinar, and in particular to our selected speaker. Today, we asked to present not only their project, but also in particular the lesson learned and of all this project and the outcome of this webinar. Furthermore, the experience of the NESOI projects related to the, let's say, technical assistance to the EU islands was included too. I think after all the discussion, after all the questions session in the round table, we can close here the workshop. We have just 1 minute. Thank you again, everyone, and please follow our projects in the website, in the social media, and we'll keep in touch. Goodbye, everyone.
Thank you very much. Thank you.
Goodbye. Thank you.
Thank you.
Thank you very much. Take care.
Goodbye.
We'll keep in touch.
Yeah.